Right, hello everyone. I am Professor Caudill. Today we're on 35. 35. Let's throw in a dart. Got a little nice picture here. So, dart is thrown horizontally. So, V not X is 10. Okay, so X final displacement or final position is 2.4 meters. Okay, so they want to know how far. Okay, so I should say, okay. So we know V not Y. No, we know acceleration of the Y is negative 9.8. So they want to know how much. They want to know Vy. No, they want to know Y. Okay, so I do just want to check and see if this is just the three variables we're working with. So let me try. So they have V not X 10. Okay, so they say V not Y 0. So thinking about the velocity and Y. So it does kind of make sense. Okay. And I wanted to use X and X naught for and they're using ensure gravity is ensure gravity is positive or a negative value based on the context and most reasonable. Okay, let's see if this changes any of our answers. Okay, so now I've fixed it, so now it says negative 9.8. Okay, so what's wrong here? This final vertical position is not right. This is what we're solving for. So this is not right. Everything else looks good. So we can say y naught is 0. I think so we're solving for y. That's what we're solving for. Okay, so I think we would use one of these displacement functions. So you have to think darts getting thrown this way. It's going to, we're trying to find this distance. To y. So we need to know y is, so there'll be negative gravity. We don't know t, so that's a problem. So maybe we use equation 5. We do okay, so I guess you could rewrite equation 5. So maybe it would be y squared is 2 -2 gravity y minus y naught plus y naught squared. No, I'm sorry. Plus velocity of the y squared. And then this is, so final velocity. So we're solving for y. So do we know the final velocity? I don't think we do. So how can we find final velocity? I know this is 0. Okay, so we know it's -2 gravity y. So y naught is 0. Okay, so if we can figure out final velocity, we know it's this. We know it's 2 gravity divided by final velocity squared of y. So we need to find final velocity. So we want to know v of y is, see, everything has a time element. We don't have time. So that's why I'm having trouble. Okay, let's see if we can. So I need to find final velocity. So how do you calculate final velocity with initial velocity, acceleration, and distance. Okay. Okay, so maybe we find the x. Okay, so we know maybe we get Vy by first getting Vx. Okay, so Vx squared okay is so there's no acceleration in the x direction, right? So that all this would be 0. So the final, so it would just be v v naught x. Okay. So now we know Vx is 10. We're assuming there's no air resistance. So there's no deacceleration Vx. Okay, so now we know Vx, what is it? Is it the velocity so is it just 10 equals 10 squared plus Vy? So is Vy equals 0? Okay, so Vy is 0. Okay, so we're saying 0 is -2 gy. Okay, so Vy is 0. Then that would be 0. Okay. Um, let's see if we can get a second opinion. I'm getting kind of stuck. Okay, so they find time by this. Distance equals v naught times time. Okay, so D is this. Okay. Formula is derived from the definition of average velocity. So this only works when acceleration is a constant. Okay. So what am I writing here? Wait, equation 0, 0. So this is going to be x minus x naught. Okay. What's the title? The acceleration a constant or a zero? It's like it's going back and forth. Okay, acceleration is 0. Okay, so I just wanted to add this just because V naught is not defined. Okay, so I've added this gradient. TV. Okay. So so we know it's going to be 2.4 equals acceleration in the x direction is 0. So we know ax is 0. So we can use this equation. 2.4 is 10t. So t is okay. Do I just go ahead and add this? Oh man, you're kidding. Okay. Okay, so I guess we're making this F11, equation 11. Find x. X is what? X is the final position. X not, essentially the initial position. T is under the time. V okay, so I should be able to I want to use equation 11. So 2.40 T 10.24. Okay, so now we know time, so now we can actually, this opens up all of these other equations. Okay, so so we can say y is negative gravity to 4/2 plus 0.24 v naught, the initial y velocity 0, so 0 plus y naught, which is 0. Okay, so let's try that. I don't know, I'm not 100% sure that y naught would be 0, but we'll try it. F5, F4. Okay, so I'm getting 2.8. I'm thinking it should be positive gravity because we're going negative. Okay, and I messed up. 4x 9.8 times 0.24 0 0. Yeah, so we're getting 0.28. Well, maybe, okay, maybe it is negative 28. So we're saying this is 0. This is the origin. And so this is -1. This is 2.4 on the x direction. So we're saying it's about a third. We're saying it'll get here. Okay, so I think that's close enough. So yeah, I think it was right to keep negative gravity. All right, so what else are they asking? How does it tell you how proficient? Okay, well it can tell you like the spread, I guess. All right, so let's see what they got. Drum roll, 0.28 How are we off by that? It's very, very annoying because, okay, we did get 2.4 seconds, 0.28 meters. Okay, and I guess maybe it's just a matter of how you draw it. Um, in our depiction, they're aiming low because um, yeah, I think these answers are right. It's just a matter of how you graph the person throwing it. So so that's pretty cool. We had to pull this equation out. So yeah, awesome. Um, feels good to get, something right every once in a while. I mean, we did have to use a language model, but is what it is. Okay, an airplane flying horizontally. Okay, so flying horizontally, V naught X is 500 kilometers hour. So it's Y naught is okay, we know gravity should really specify A of the Y is 9.8. Okay. So an airplane is flying horizontally, speed of 500 kilometers at this height. So they drop a crate here, 800 meters. So assuming no parachute opens, so they want, okay, let's say X naught is 0. So we want to find X. Okay, so do we know the final velocity? Um, well, I guess we know, no, we don't know. We know Y. We know Y is 0. X is what we want to know. So it's dropping it. We want to know this distance here. Okay. Um, I'm tempted to say the final velocity is 0 because when you hit the ground, but I don't think that's necessarily correct. You be hitting your final velocity would have a value, I think. Um, so do we? Okay. So we could probably use what can we use? We want to find x. So it's not getting accelerated in the x direction, so we could find t. So ax is 0. It's not getting accelerated in the x direction. So that means we could do x minus 0 is t 500t, but we don't know x. So that's the problem. So we can't do this because we have two unknowns here. So what else do we know? We know y naught is 800. Maybe we could say y is, no, that wouldn't work either. Well, okay, I guess we could say y tv plus x naught. So we could just say 0. We could say 0 is velocity so we could say 0 velocity in the y direction. So like I'm tempted to say like is a in the y direction equal to t vy? Because if a is a constant, let's say c, then the integral of c dt is ct plus a constant. So, you know, I could see these being the same plus a constant, and then you see these kind of parallel here. So is it just negative 9.8? No. So if it's C, then it's 9.8 E. Okay. I don't know. Like I'm kind of skeptical on this, but part of it makes sense. So let's try that. Equation 3. Final velocity is 9.8. Okay, what am I doing? I don't think this is what I wanted. We wanted F2. 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 We want Okay, so 0. Time is what we're solving for. Negative 9.8. 800. Okay, so I'm getting T is 81.6 seconds. Okay. So how much time to hit the floor? Now they want to know how far. So we want to know the distance with time. So now that we know a time, we know the final time, we can do something like this. We don't have a. Okay, we can do this because this would be 0. So this would be. And I can see how like this equation and this equation are like the same because in a certain way. Okay. Um, so what do I want to do here? T V naught, do we know V naught X? We do. Okay, so we can try equation 4. Final position. That's what we're solving for. Acceleration is 0. Time 81.6. It's going 500. Starting at 0. Okay, so X is 40,800 meters. Okay, so let's see if we get a second opinion that matches what we just got. And then if it matches, we can be very happy. So looks like they're not getting the same thing, not getting the same thing. So we're way off. It's really annoying. So what did they use? 1/2 GT. So this was wrong. I'm gonna say. Um, okay, so they're doing why not is why not is GT2. My equation has final X. So I think we need a new equation. I want a new symbol to, let's see. let's rewrite this so it's okay. So we have two A's. I don't know what this is. So we use this here. Let me rewrite this as a mag. A mag. And where they have it, a mag. Okay, works for me. Um, okay. Okay. All right, so what are we doing? We want to make a new symbol. Okay, can I just combine these? Put it in one line. Okay, so these are my symbols. Okay, so we want a new symbol. It's going to be B. It's going to be Y, not, and that's going to be Y, not. Okay. Which one? This, I don't like this. I'm just gonna delete this one. Motion two dimensions. Okay, so what am I doing? I want to add a new equation. Equation is y not is negative 9.8. It's 8 times t over 2. Okay, so a 12. It's going to be y not y not. It'll be t, and that's it. It's going to be a simple. Oh, I guess we should do a. Yes, okay. So it will be a. Okay, a t. So we want to do solve equation. It should be 11. It should be 12. This will be y not is y not. A is a. Okay. So y not. Enter the oh, why not AAT. Okay, so in this case, So our why not is using equation 12, 800 negative 9.8 t. Okay. So 163 seconds. It's a t squared, isn't it? Yes, it's a t squared. Okay, so we have to fix that. Equation 12. It's t squared. Okay. Equation 12. Initial height is 800. 9.8 t. Okay. And would negative 9.8 work as well? Equation 12, 800, negative 9.8 t. Okay. It's reading 12.7. Okay, and then you plug that into that. So they plug this into this to get the initial velocity in the x direction. Can I make it a v naught x? V naught x. We already have a v naught x. Okay, so we already have a v naught x. Okay, so then we would choose equation 11. We would say the final position is what we're solving for. Initial position is 0. Time is 12.7. Initial velocity is 500. So we get 63,000. Okay, and we had to convert, man, we had to convert this into and what a tricky problem. What do they even do? Converting hours, converting this to meters per second, kilometers to meters per second. Okay, so they had to convert this to 138. Okay. So x0, 12.5. Okay. 138.9. We get 1764. Okay. There's a lot of equations. It's kind of like a jigsaw puzzle, putting everything together. But I think I'm getting some intuition. It's kind of tricky because like these first five equations are from an earlier chapter, so they're not like specified. Like you have to kind of convert it in your head, like x. Okay, that's a is ax, a in the x direction. V naught, that's v not x. Um, so I'm also debating. So you know how we can make vector with arrows. I don't know if we can make vector with an arrow and a subscript. Let me try. So we know VVV. VVV is this, so okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So display a V naught. See what I mean? It's okay, what if I spliced V into here? Okay, V naught. Okay, that doesn't work either. Um, just put an F in front. That would make it possible. Okay, that doesn't work. Yeah, so it just does not work. So that's why I'm kind of hesitant of kind of doing anything else with the vector arrows, because you can't really subscript with the vector arrows in SymPy, as far as I know. So that's kind of a bug. Maybe I can make a little ticket with SymPy. Um, So let's say yeah, I might make a ticket on Senpai and see if I can. I want to splice it. It doesn't work. So I might just post this on the Senpai GitHub. Um, yeah, so thanks for hanging out. I'll see you guys next time.